Good evening, all. Welcome to Unacademy. This is Bhanu Prakash, expert in GATE and ESE. I did MTech from NIT Kurukshetra. I have 10 years of teaching experience. My subjects are electrical machines and power electronics. BPC 10 is my referral code. So use this code, you will get 10% discount on Plus subscription as well as Iconic subscription. And what are the benefits of the Plus and Iconic subscription? So by taking Plus subscription, you can get live classes from the top educators of the country, and also you can get structural schedule for 3 months, 6 months, 12 months and 24 months. And another one, unlimited practice questions for subject wise and topic wise. Similarly, test series for subject wise and topic wise. And Iconic subscription, one more subscription is a Iconic subscription. So by taking Iconic subscription, you can get more benefits in addition to these four. So you will get some extra benefits such as personal coach, study planners, expert guidance, ESE mains questions and answers. Personal coach means we will assign a coach. He will guide everything until you get a job or until to crack your exam. And second one, study planners. So we will provide the proper study planners, how to prepare for GATE and how to prepare for the ESE exams. And third one is a expert guidance. We will provide the expert guidance which is very useful for your GATE and ESE preparation. And fourth one is a ESE mains questions and answers. We will provide the ESE mains questions and answer. So this Iconic subscription is a best suitable for ESE preparations. Okay, and BPC 10 is my referral code. Okay, use this code, you will get 10% to discount on Plus subscription as well as Iconic subscription. So this day, what is the price for the Plus and Iconic subscription? So Plus subscription is available for 12 months, 18 months and 24 months. So per 12 months, the fee is at 27,225 rupees. For 18 months, fee is 34,650 rupees. For 24 months, fee is 39,600 rupees. BPC 10 is my referral code. Use this code. You will get 10% discount on Plus subscription as well as Iconic subscription. Another subscription is Iconic subscription. So it is available for 12 months and 24 months. For 12 months, fee is 45,225 rupees. Okay, for 24 months, fee is 66,600 rupees. Okay, all of you got it? Good evening, all. Okay. In previous class, we had discussed about what is meant by generators and what is meant by the motors here. So today we will discuss about working of DC generators and its EMF equations. So how does EMF induced in the generators? Okay, this part we will discuss. So before going to discuss about these topics, let us know what is the terminology used in this diagram. So this is the N comma S is a field poles and ABCD is a armature coil in which AB and CD are armature conductors. So this axis is the Q axis and it is a D axis here. Here I have shown C1 and C2. So where C1 and C2 are the commutator segment, B1 and B2 are the braces, and P and Q are load terminals. So this is let us assume generator is rotated by the prime mover in a clockwise direction. So these are the terminals, or these are the terminology used in the working of the DC generators. So first one, here let assume let N comma S are field poles. Okay, what is the function of the field poles here? So it creates, okay, field poles are required to create the magnetic flux in the machine. So now these are required to create magnetic field in the machine. Okay, and second one, ABCD is there. Okay, what is the meaning of ABCD? ABCD is a armature coil. ABCD is a coil in which AB and CD are armature coil. So which coil it is? A single turn coil, just like only one turn. So that is a ABCD is the single turn coil. Okay, for our convenience, so I have taken one is a single turn coil. So in the ABCD coil, AB is a one armature conductor and CD is a another armature conductors. Okay, so now here AB and CD are armature conductors. Armature conductors here. Very good, Sanjana. That's correct. N comma S is the create field poles. These are required to create the magnetic field or flux in the machine. And next one, B1 and B2. So what are the B1 and B2 here? So braces. Okay, carbon braces. Okay, braces. What is the function of the braces? To collect the current from the commutator segment. Okay, this function of the braces is required. So to collect current from commutator segments. Commutator segments here. Got it? And C1 and C2. What is the meaning of C1 and C2 here? C1 and C2 are commutator segments. Okay, so in the diagram, AB conductor is connected to the, so this commutator segment C1, whereas CD conductor is connected to the commutator segment the C2. Okay, so AB conductor is connected to the commutator segment C1, whereas CD conductor is connected to the commutator segment C2. So whenever armature is rotating, commutator also will be rotating, but braces are stationary. So braces always contact with the commutator segment. Suppose if it is a rotating like this, the brace is placed on the commutator. So brace is stationary part, commutator is a rotating like. So it always contact with the commutator segment. Okay. So this is the B1 and B2. And what about the P and Q terminals? So these are load terminals of generator. Load terminals of generators. Got it? Sanjana sir, I recently came to know about this initiative. It is very helpful. Thank you. Good evening, Ramakrishna. All of you clear? These are the terminology used in the generator. N comma S is the field poles. ABCD is a coil in which AB and CD are armature conductors. B1 and B2 are the braces. Braces are required to collect the current from the commutator segment in the generator. And P and Q are load terminals here. So there are the two axes. One is a axis between the two poles. Suppose this axis between the two poles, okay, it is a the direct axis. It is also called the D axis here, or sometimes it is also called polar axis here. And next one, Q axis, axis which is perpendicular to the direct axis. So that is the quadrature axis and the D axis. Quadrature axis or Q axis. Okay. So here the D axis in the means it is nothing but direct axis. It is also called polar axis. What is the meaning of polar axis? The axis between the two poles is called the polar axis. And the Q axis means the axis which is perpendicular to the direct axis, that is a interpolar axis. Interpolar axis or quadrature axis. Okay. Bharat, good evening. Ramakrishna, good evening. Sanjana. Okay. Pavan, good evening all. Okay. All of you clear now? What is the meaning of the D axis and the quadrature axis? Axis between the two poles is called the D axis, and axis which is perpendicular to the direct axis is called the quadrature axis. These are the terminology used in the working of the DC generators. Now let us assume generator is rotated by the prime mover. So this torque is a prime mover torque. Okay, generator is rotated by prime mover in a clockwise direction. So when it is rotated in a clockwise direction, then what will happen? Suppose if we take this is the one rotation. So complete one rotations, like the armature core is a cylindrical structure. So what will happen? Suppose we have a one position 1 P1, and this is the position 2 P2, and this is the position 3, okay, P3 here, and this position is a P4. Okay, got it point? So whenever DC generator is rotated by the prime mover in a clockwise direction. So at position 1, suppose in this coil, at position 1, AB conductor is under the influence of the north pole, and CD conductor is under the influence of the south pole. Got it point? So at position 1, AB conductor is under the influence of the north pole, and whereas CD conductor is under the influence of the south pole. So now after some rotation, okay, after the some rotation, suppose these are the conductor, AB conductor, and this one is my right hand is a CD conductor. So now after some rotation, then what will happen? No conductors are present under the influence of the north pole and south pole here. So here is AB conductor and CD conductor after some rotation, just like after 90-degree rotation. So that's the coil is present along the quadrature axis. Next one, after some rotation, that is the position 3, AB conductor is under the influence of the south pole, whereas the CD conductor is under the influence of the north pole, exactly in the reverse manner. Next one, after 90-degree rotation of the armature coil, the no conductors are present along under the influence of the north pole and south pole. So which is present along the quadrature axis. Okay. Now we will discuss, okay, when armature coil is present at a position 1, then what will happen? EMF induced in the armature coil A, B, C, D. When the armature coil is present along the quadrature axis, what will happen? Whether EMF induced or not. Okay. Similarly, when armature coil is present along the direct axis, okay, this is the direct axis at position 3, then what will happen? EMF induced or not? Okay, that point we will discuss. Now similarly, when armature coil is present along the position 4, okay, along the quadrature axis at position 4, so what will happen? Whether EMF induced in the AB conductor or not. Okay, this is nothing but working of DC generators. What is the exact meaning of working of DC generator? So working in the sense, how does EMF induced in the DC generators? So at different positions, Okay, position 1, position 2, position 3 and position 4. Okay, all of it clear? Is that clear, everyone? So what points we are going to discuss in this topic? So when the position 1, at position 1, what will happen? EMF induced in the AB conductor and CD conductor. Similarly, at position 2, what will happen? EMF induced in the AB conductor and the CD conductors. Got it? Right. So we have some positions. Initially, let assume DC generator is rotated by prime mover in clockwise direction. Okay, at a speed of n rpm. So it is rotated at a clockwise direction at a speed of the n rpm here. So initially at position 1, so this is at position 1, then what will happen? See, so all of it clear my point? So this is the position 1. Okay, at the position 1 here. Got it? So now this is the at position 2. Okay, and similarly this one is at position 3. And another one at position 4. So like this, the coil is rotated in the like. So position 1 to position 2, then position 2 to position 3, and position 3 to position 4, and continuously it repeated like this. So 1, 2, 3, 4. Okay, like. So initially what will happen when armature coil is at position 1? Okay, at position 1. So along the direct axis, okay, which is present along the direct axis. So what will happen in the armature coils? Okay, so always flux lines are passing from, suppose this is the direction of the flux. Okay, here I have shown with the red marks. So this one is the always flux lines are passing from, so north pole to the south pole. Okay, this is the direction of the flux. So all the flux lines are passing from north pole to the south pole here. Okay, and this at position 1, what will happen? Suppose here is let us assume how many flux lines? 1, 2, 3, 4, 5, 6. Okay, 6 number of the flux lines are there. So 6 or 8 number of flux lines. So now here is the total flux lines. Let us assume the flux lines is equal to the flux lines, that is equal to, so suppose 6 number of the flux lines. Okay, let us assume 6. So out of the 6, then what will happen here? Okay, out of the 6 here, so only 4 flux lines are linking with the coils. Okay, 4 flux lines are the linking. So now that means the flux linking is a minimum. Okay, flux linking is a minimum. So out of the total flux lines, the 6 is there. So when the coil is present at this position, so like this along the direct axis, so what will happen? So all the, suppose out of the 4 flux lines, suppose this is 1, 2, 3, 4 flux lines are there. For example, fine. So this is the armature coil. So out of the 4, how many flux lines are? Okay, only 2 flux lines are linking with the coil and 2 are cutting. Got it? Fine. So 2 flux lines are linking and 2 flux lines are the cutting. So that means at this position, okay, here is when armature coil is present at the position 1 along the direct axis. So this is all the flux linkage okay, is a minimum flux linkage. Flux linkage is a minimum value. But flux cutting is a maximum. Okay, flux cutting is maximum value here. Got it point? So now at this time, what about the angle between these two here? So this is the axis, okay, field axis. Okay, this is a field axis here. Now again, this one is a armature axis. Okay, like this. So armature axis. So now what about this here? Armature axis, the angle between these two here. So now here, this is the armature axis. So that here angle is a 90. Okay, this is the theta is equal to the 90 degrees here. So all of you got it point. When armature coil is present along the direct axis at position 1, flux linkage is a minimum, but flux cutting is a maximum one. I repeat once again, listen, very important point. Suppose here is this is the one coil, okay, one conductor. Suppose here is a AB conductor, okay, this is the AB, and this one is the CD conductor. So at this position, AB conductor is under the influence of the North Pole and CD conductor is under the influence of the South Pole. All of you got it point? Just assume this one is the AB conductor. All the flux lines are passing from North Pole to the South Pole. So here is this is the direction of the flux. Okay, out of the 4 fluxes, only 2 flux are linking. That is the flux linking is a minimum. But 2 flux lines are linking and these 2 are cut by the conductors. So this is a flux cutting is a maximum value. That is the difference between flux linking and also flux cutting. Okay. Are you getting my point, Sanjana? Okay, this why I have written flux linkage and flux cutting. Just take this is my 4 flux lines. Okay, let us assume my 4 flux lines are there. So out of the 4, this is the 2 flux lines are linking with the conductors, and out of the 4, 2 only linking. That's the flux linkage is the minimum. But what about the cutting action? 2 linking, okay, 2 flux lines are linking, but these 2 flux lines are cut by the conductors. So that means flux link cutting is a maximum value, just like 100%, and this one is the 50%. Are you clear now? Okay, so now here angle between these two here 90 degrees. So that EMF induced in the AB conductor EAB is equal to, so we can write sine 90 degrees. Okay, or BLV, EMF induced in the AB conductor EAB is equal to, so BLV the sine theta, where theta is equal to 90 degrees, the sine 90 degrees, sine 90 degrees is equal to, so maximum value BLV. Similarly, EMF induced in the CD conductor, so that is equal to BLV the sine theta. So now here BLV sine 90 degrees, so now it is equal to BLV only. So what is the net induced EMF? Net induced EMF is equal to EMF induced in the AB conductor plus EMF induced in the CD conductor. So now it is equal to BLV plus BLV, that is a 2BLV1. So this is the maximum value of induced EMF in the single turn coil. Okay, all of you got it? So next one, the at position 2. Okay, position 2 means what? So initially here angle between the armature axis and field axis is equal to 90 degrees. Okay, so now what will happen? Theta here, theta is equal to 90 degrees after 90 degree rotation. So now this is 90 plus 90 degrees. So now it is equal to 180 degrees. Okay, so at this condition, what will happen? See, so all the flux lines are, okay, this is the out of the 4, suppose. So there is a flux lines are passing into the coil.
but all the flux lines are passing into the coil, but no flux is cut by the AB conductor and CD conductors. So this is the position of the AB conductor, okay, AB, and this one is the CD conductors line. So when armature coil is present along the quadrature axis, okay, this is the along which axis here? The Q axis. So along the quadrature axis, the no conductors are present under the influence of the North Pole and South Pole. So at this position, what will happen? All the flux lines are passing into the coil. Suppose, so this is the my, okay, it is the one. Are you clear my point? Are you seeing me? This one. Okay. Okay. See here. Suppose just assume this is the AB conductors. All of you clear my point? This one is the AB conductor and the CD conductors here. AB conductor and the CD conductor. So when armature coil is present along the quadrature axis, what will happen? All the flux lines are passing into the coils. Okay, this is the direction. All the flux lines are passing into the coil, but no flux is cut by the conductors. Okay, so what it means here? Flux linking is a maximum, but cutting is a minimum value. Okay, so when armature coil is present along the quadrature axis, so flux linking, okay, all the flux lines are linking. Flux linkage is a maximum value, okay, maximum. But what about the flux cutting action? So this flux cutting is the minimum. So if there is no flux cutting action, no EMF induced. So with respect to theta also we can find out. So now EMF induced in the AB conductor, so that is equal to BLV sine theta. So now here this is the BLV, the sine 180 degrees. Okay, 180 degrees here. Now this is equal to 0, and EMF induced in the CD conductors, so that is the BLV sine theta. So equal to BLV the sine 180 degrees. So it means that, so that is equal to 0 degrees here. So what is the net induced EMF? E net is equal to EMF induced in the AB conductor, EMF induced in the CD conductor. So that equal to the 0 here. All of you got it point? When armature coil is present along the direct axis at position 1, okay, a flux cutting action takes place at a maximum rate, so that EMF induced in the armature coil will be maximum value. When armature coil is present along the quadrature axis, the no flux is all the flux lines are passing into the coil, but no flux is cut by the conductors, so that EMF induced in the armature coil is equal to 0. Okay, yes, have you got it? Pawan, Sanjana, Bharat, is it clear or not? Very, very important. If you know these things, you can easily understand the DC machine. Otherwise, it would be difficult to understand. Okay. So next one, at position 3, then what will happen? position 3 means okay 180 degrees theta is equal to 180 degrees plus the 90 degrees. So that is equal to after 90-degree rotation. So that is equal to theta is equal to 270 degrees. After 90-degree rotation, this conductor here, conductor the CD under the influence of the North Pole, and conductor the this is the conductor AB, so under the influence of the South Pole as shown in the figure. So now which axis here? So this axis is a exactly here. So this one is a direct axis. Okay, direct axis here. So when armature coil is present along the direct axis, what will happen? The flux linkage is a minimum. Okay, this the flux, the linkage is a minimum. So that is the only the linkage is the minimum value, but cutting is a maximum. So out of the four, two flux lines are linking. Okay, suppose here, so one out of the four flux lines, okay, two are linking and the two are cutting. So that is the flux cutting is a maximum values here. When flux cutting is the maximum, EMF induced in the armature coil will become maximum values. Okay, so therefore EMF induced in the AB conductor, so that is equal to the BLV. So that is the BLV sine the 270 degrees. So now it is equal to minus the BLV1. So EMF induced in the CD conductors. So that is the BLV the sine 270 degrees. Now it is equal to minus the BLV. So what is the net induced EMF? E net is equal to minus, so BLV value, 2 BLV values here. So this is the net induced EMF. So now it is exactly position 1 but in the reverse direction. So at position 1, AB conductor is under the influence of the North Pole and CD conductor is under the influence of the South Pole. But at position 3, AB conductor is under the influence of the South Pole, whereas CD conductor is under the influence of the North Pole. Okay. Next one, at position 4, then what will happen? So theta is equal to after 90-degree rotation. That means 270 degrees the plus 90 degrees. So it is equal to 360 degrees. 360 degrees is nothing but, so that is equal to 0-degree rotation. So when armature coil, so which axis here? Okay, this axis is a quadrature axis. So when armature coil is present along the quadrature axis, all the flux lines are, okay, these flux lines are passing into the coil, but no flux is cut by the conductors. Okay, so that's why we can write here flux linkage is a maximum value, flux linkage, so that is equal to maximum. But what about the flux linkage? Okay, flux cutting. So flux cutting is a the minimum value here. Okay, min. So therefore EMF induced in the AB conductor, so E is equal to 0. EMF into the CD conductor also equal to 0. So what is the net induced EMF? Net induced EMF also equal to 0 here. So that what we conclude here in this discussion, when armature coil is present along the direct axis, okay, when armature coil is present along the direct axis, flux cutting action takes place at maximum rate, so that EMF induced in the armature coil will be maximum value. Okay, when armature coil is present along the quadrature axis, so all the flux lines are passing into the coil, but no flux is cut by the conductors. Okay, is that clear, everyone? Okay, so now we will discuss about what is the positions here. Okay, so we have a two statements. So that is the first one, when armature coil is present along direct axis, along the D axis, along direct axis. Okay, flux cutting action takes place. Flux cutting action takes place at maximum rate. Okay, maximum rate, so EMF induced in the armature coil, will be maximum value. Okay, got it? So next one, another point. So when armature coil is present, when armature coil is present along quadrature axis, okay, Q axis, okay, all the flux lines are passing into the coil, but no flux is cut by the conductors. No flux is cut by armature conductors. Due to which no EMF induced, due to which EMF induced in the armature coil is equal to EMF induced in coil is equal to 0. Okay, so these are the very important point. So whenever armature coil is present along the quadrature axis, when armature coil is present along the direct axis. Okay, so here we have the waveform. Okay, what will happen? Listen. So this is a 0 degree position. So 0 degree means what? It is the position 4. Okay, position 4 here. Okay, like, so this is a 0 degree. Okay, that is the position 4. Okay, position. And next one, 90 degree position. So that is the 90 degree positions, and that is the position 1, P1 position. And this is the 180 degrees. Okay, it is the position 2. Okay, next one, this is the 180 degrees, that is the 270 degrees. So that is the position 3. And next the 360 degrees. So it is the position 4. So when exactly at this point, okay, this is a, when armature coil is present at the position 4, so no EMF induced in the armature coils. Okay, now this is the nothing but exactly here. So this is a, so that is the Q axis position. Okay, Q axis. So when armature coil is present along the Q axis at position 4, no EMF induced in the armature coil. When armature coil is rotated by the frame mover from the position 4 to position 1, so EMF induced in the armature coil also increases and reaches the maximum value. So exactly at position 1. Okay. Next one, when armature coil is rotated by the frame mover, so frame mover at a speed of the n from the position 1 to position 2. So now here this is the EMF induced in the armature coil decreases, okay, decreases and reaches the 0 exactly at the position 2. So next one, when the coil moves from the position 2 to position 3, so here EMF induced in the armature coil increases, okay, increases here, and reaches the maximum value exactly at the position 3. Now this when the armature coil moves from the position 3 to position 4, so EMF induced in the armature coil is it? So that is decreases to the 0 here. So this is the positive value of here, the plus maximum value E maximum, and this one is the negative maximum values here. Okay, this is the negative maximum value of induced EMF. So now this axis is what? Okay, it is the direct axis. Okay, so EMF induced in the direct axis. Okay, D axis here, and this one is the Q axis. Okay, Q axis here. So EMF induced in the armature coil at position 4, okay, 0 degree position, that is equal to 0. So this type of EMF is known as the side here, the time varying nature of the induced EMF. So this is a EMF induced in the armature coil. EMF induced in armature coil. So it is the time varying nature of the induced EMF. So that is the AC induced EMF, time varying the nature, time varying nature here. So that is the EMF induced in the armature coils. Okay, got it, all of you? So what is the meaning of how does EMF induce in the DC generators? Okay, is that clear everyone? So now let us discuss action of the commutator. So what is the meaning of action of the commutator here? Or commutation action. So is the process of the reversal of the current in the armature coil through commutator segment and braces is known as a commutation action or action of the commutators here. So it plays very important role in the DC machine here. So how do we define the commutator action? So the process of reversal of the current. Process of reversal of current in the armature coil, through commutator segment and braces is called commutation or action of the commutator. Okay, so now this is the definition point of view. The process of the reversal of the current in the armature coil through commutator segment and braces is known as the action of the commutator or commutation action. So what will happen exactly here? So we know that suppose it is a one armature coil. Okay, this is the armature coil positions. Okay, this is a armature coil position. So initially at position 1, okay, this is the position 1, P1. Okay, I have said P1. So next one after that here, this is the position 2, P2, and this is the position 3, P3, and this one is the position 4, the P4 here. So now P1 in the sense, P4 is the 360 degrees, that is the 0 degree position, and P1 is the 90 degree position, and it is a 180 degree position. And similarly this one is the 180 degree position and the 270 degree position. Okay, like so we can discuss this commutation action in the two parts. Okay, like so we will discuss about, so whenever armature coil moves from, okay, this armature coil So moves from the position 1, position 4 to position 2. So this is the one part. Okay, it is a case 1. Okay, like so when armature coil moves from the position 4 to position 1. So that means 0 degrees to the 180 degrees. So at this position, what will happen? When armature coil moves from the position 4 to position 1, AB conductor is under the influence of the North Pole, whereas the CD conductor is under the influence of the South Pole. So exactly at position 1, 180 degrees and 0 degrees, so EMF induced in the armature coil is equal to 0. But from year to year, so this is a, so from the position in between the 0 to the 180 degrees, okay, 0 to the 180 degrees here. So some very EMF induced in the armature coil, but it is a maximum exactly at this position. Now similarly, so another case too, when armature coil moves from the position position 2 to position 4, okay, position 4 here. So now exactly from in between these two here. So now here this we called as the case 2. So then what will happen? Current in the armature coils. Okay, this part we will discuss. Okay. So all of you can find what is the meaning of action of the commutator. So the process of the reversal of the current in the armature coil through commutator segment and recess is called the commutation action or action of the commutator. So I have divided this into the two parts. So first case 1 and case 2. In the case 1 is the whenever coil moves from the position 4 to the position 2. Okay. Now is it coming now? Just verify once. Is it okay? Again, is it coming? Just verify once. Okay. I think it's not coming, right? Just wait a minute. Now, please tell me now. Is it okay now? Okay, just The process of reversal of the current in the armature coil through commutator segment and presses is called the commutation or action of the commutator. Okay, again you get a problem. Is it okay now? Okay, no problem. Sanjana is correct. Okay, listen. Suppose from the case from the 0 degrees to the 180 degrees. What is the meaning of 0 degrees to the 180 degrees? So it means that from the position 1, okay, sir, position 4 to the position 2. So exactly in between the position 4 to position 2 ones here. So at 0 degrees we know that here the at 0 degrees EMF induced in the armature at 0 degrees EMF induced in the armature coil, okay, EMF, so that is equal to 0. Okay, similarly at 180 degrees then, okay, at 180 degrees EMF induced in the armature coil also equal to 0. So why? Because at 0 and 180 degrees armature coil is present along the quadrature axis, so that EMF induced in the armature coil is equal to 0. But in between these two, okay, in between the degrees, so for example 10 degrees, okay, 90 degrees, and also here at this position. So at this position, when armature coil moves from the position 4 to position 2, so here is a what will happen, okay, in the armature coil. So whenever armature coil, don't write, listen. So when armature coil is rotated by prime mover from the position 4 to position 4 to position 2, okay, AB conductor, armature AB conductor is under the influence of north pole. Okay, am I right? AB conductor is under the influence of the north pole, whereas the CD conductor is under the influence of the south pole. Okay, this is happen when these two conductors are present, okay, like this manners. So therefore, how do we find out in the simplified diagram manner? So here I have taken, suppose this is a AB, this is the north pole, okay, so north pole here, and this one is a the south pole. Okay, north pole and south pole. So always what will happen? The flux lines are passing from north pole to the south pole. Okay, this is the direction of the flux lines. Okay, whenever the armature conductor is rotated by the frame mover, the from position 4 to position 2. So here is AB conductor is under the influence of the north pole. Okay, this is the AB conductor, and CD conductor is under the influence of the south pole. Okay, this is the CD conductor is under the influence of the south pole. So at this case, similarly, here is the AB conductors. Okay, just let us draw the equivalent diagram. So AB conductors, it is the A and this one is the B. So at this position, AB conductor is connected to the commutator segment C1. Okay, and which is the brush is placed here. Okay, this is the position of the brush. Okay, so brush B1. Okay, B1 position. So next one, CD conductor is the CD conductor is placed under the influence of the south pole. Okay, this is the CD conductor. So which is connected to the commutator segment the C2. Okay, commutator segment C2 here. So got it point. So this is a C2, and this position is a position of the brush is a provided. So now here this is the brush B2 and commutator segment is the C2 here. Okay, C2. So now what will happen from these two terminals from the brushes? So here the from brush terminal load is a connected. So now list this load terminals. Okay, like so P and the Q terminals. Okay, these are P and Q terminals. So this is a single line diagram. So next one, the whenever the AB conductor is, so now it is rotated by the frame mover. Okay, frame mover torque is TPM here. So whenever it is rotated in a clockwise direction, the force applied on the AB conductor is upward direction. Okay, am I correct? So next one, force applied on the CD conductor is the downward direction. So force applied on the AB conductor is upward direction. Force applied on the CD conductor is downward direction. So according to Faraday's laws of electromagnetic induction, so EMF induced in the AB conductor, okay, EMF induced in the AB conductor, and similarly EMF induced in the CD conductors here. So how do we obtain this direction of the induced EMF? So direction of induced EMF can be obtained by using Fleming's right hand rule. So now apply the Fleming's right hand rule at position this here at AB conductor and the CD conductors here. So by FRR you will get, so that is the cross at the AB conductors. So dot mark at the CD conductors here. So this is the cross mark and this one is the dot mark here. So what is the meaning of cross mark here? Current flows from the A2 to B terminals. Okay, A to B terminal. And current flows in the CD conductor from the C2 to D terminals here. So now here this is a current away from the brush. You can consider as a positive group of the brush. Current towards the brush, it is a negative group of the brushes here. So but current flows from the load terminal P and the Q terminals. Okay. So this is the direction of the current. Okay, this is the load. So load, and this one is the armature coils. So what will happen in the coil? Okay, in coil the current flows from, okay, in a coil. So current from A in a coil from the A to B. Okay, A to B in the AB conductor. So then after from the C to D. Okay, here C to D in the CD conductors here. But in load, okay, current flows from, so which parameters? From the P2, okay, P to Q terminals. Okay, these are from the P to Q terminals here. So this is the in the first rotation, first half rotation of the coil. So next half rotation, what will happen in the armature coil? See. So suppose here from 180 degrees to the 360 degrees. As I earlier mentioned that, so 180 degrees to the 360 degrees. Okay. So therefore here at 180 degrees to the 360 degrees. So that means from the position, okay, 4 to, okay, position 2 to position 4. Okay, this is the position 4 here. So when armature coil, okay, when armature coil is rotated by the frame mover from the position 2 to position 4. So what will happen? AB conductor is under the influence of the north pole or south pole. Okay, tell me. At this condition, AB and CD conductor positions. Okay, at this condition, when armature coil is rotated by the frame mover, when armature coil is rotated by prime mover from position 2 to position 4, from the position 2 to position 4. Okay, position 4. So AB conductor is under the influence of under the influence of north pole, under influence of south pole, and CD conductor is under the influence of north pole. Okay, got it point? So what will happen? S is a south pole and N is a north pole, right? AB conductor is under the influence of the south pole, and CD conductor is under the influence of the north pole. So now let us take, so this is the north pole. Okay, it is a north pole here, and another pole. Okay, this one is the south pole. So what will happen? Always flux lines are passing from north pole to the south pole. So this is the direction of the flux line. So whenever at this position, okay, whenever the conductor moves from the position 4 to position 2 to position 4, so that means 180 degrees to the 360 degrees. So now AB conductor is under the influence of the south pole. So whereas CD conductor is under the influence of the north pole here. So AB conductor means, okay, this is the AB conductor. So which is connect here, the CD conductors. So now it is the C terminal and the D terminal. So which is connected to the commutator segment C2. Okay, commutator segment C. So next one, it is the AB conductors. Okay, it is the B terminal. Okay, and the A terminal here. So which is connected to the commutator segment C1. So brushes are stationary. Okay, here is the brush B1 only. Okay, this is the brush. So B1, and this brush is the B2. Okay, this is the B2. So brushes are the stationary, but commutator and armature coil will be the reverse. So there in this case, so this is the load terminals. Okay, load is connected here. So this load terminals, okay, are the P and the Q terminals. Okay, P and Q terminals here. So what will happen? So it is rotated by the frame mover. TPM is in the clockwise direction. So when it is rotated by the frame mover, so force applied on the CD conductor is upward direction. The force applied on the AB conductor is the downward direction. So according to the Faraday's laws of electromagnetic induction, whenever a rotating conductor is placed in the stationary magnetic field, and EMF induced in the CD conductor as well as EMF induced in the AB conductors. Okay, like EMF induced in the CD conductor as well as EMF induced in the AB conductor. So how do we obtain? So this one is this direction of induced EMF can be obtained by using the Fleming's right hand rule. So by applying the flaming right hand rule at the CD conductor, we get the cross mark, and this is the dot mark here. So cross at the CD conductor and the dot at the AB conductors here. So what is the meaning of the cross here? Suppose a observer is sitting here, the current away from the observer. Okay, current away from the observer. Current flows in the armature coil. Okay, in coil. Okay, in coil, current flows in the armature coil. So from D to the C terminals. Okay, D to C terminal. Current flows in the AB conductor here. Dot mark means towards the observer. So that means the from, so here B to A terminals. Okay, B to A terminal. So this is the current directions in the armature coil. So next one, the brush here, current away from the brush. So this is the assume as a positive brushes, and current toward the brush. This one is the negative group of the brushes. So now current flows from the this terminal to so P2 and Q terminals. So in case of the load, okay, here in the load, the current flows from the P2, okay, so P2 Q terminal only, okay, Q terminals. So now if we write this equation, so this is the first positive half cycle. So then what will happen in the negative half cycle C? So this we have taken positive half cycle, and 2 cycles we will discuss. Okay, from 0 to 180 degrees, and okay, it is a so it is the here, this is a positive half cycle and the negative half cycle. So this is the 0 degrees, okay, 180 degrees, okay, 180 degrees to that is the 360 degrees line. So from the positive half cycle, and there is another load current also we are discuss about the load current here. It is the armature current IA, and current flows in the load is a IL current. Okay, IA and IL. So in the positive half cycle current here, the flows from the A to B terminals. Okay, in the positive half cycle, so current flows from the A to B terminal and the C to the D terminals here. So here in the load also current flows from the A to the, this is exactly the P to Q terminals. Okay, Q to P terminals here. But in the negative half cycle, the negative half cycle means from 0 degrees, 180 degrees to the 360 degrees, current flows from the reverse D to C terminal and B to A terminal. So initially here A to B and C to D. So this is the exactly in the reverse case. So this one is the D to C terminal and a B to A terminals here. But in the load, okay, what is the current direction? Only P to Q terminals, same as that of the previous cycle. So now this one is the load current IL, okay, P to the Q terminals. So what we conclude here? So this is the current is a AC nature of the current. Okay. Now this current is a DC nature. Exactly we have a pulsed DC, but only 2 conductors are using. That's why we will get 2 pulses. Suppose more number of conductors are used, you will get the n number of the pulses here. So that means here this you will get the, if you place the more number of conductors in the armature coil, you may chance to get the pure DC nature of the current. So the complete action takes in the commutator of the DC machine. So commutator converts the AC current to the DC current in case of the DC generators. Okay, are you clear point? What I am telling you? So commutator converts. Okay, there is a note here. Note, the commutator converts the AC to DC in DC generator. Okay, in generator. So act as the rectifier. Act as the rectifier. Okay. All of you got it, my point? the reversal of the anode current through the commutator segment. Okay, reversal of armature current through the commutator segment. Through the commutator segment and braces is known as a commutation of the DC machine. Okay, is that clear, everyone? So, how does EMF induce in the armature coil? What is the action of the commutator? Commutator converts AC to the DC in the DC generator. So, act as a rectifier. If you have any questions, you can ask. Okay. So now let us discuss about the EMF equation of the DC generators. So how do we get EMF equation of DC generators here? So initially, okay, thank you. So how do we derive the EMF equation of DC generators? That part we will discuss. So let us assume, okay, here P is the number of the poles. Okay, let P is nothing but, so it is a number of the poles. So now here the PE in this case, the let phi is a, okay, this of phi is nothing but, so flux per pole. So now what it means here, this phi is a flux per pole. One pole create the phi amount of the flux. Therefore, the total flux in the machine, okay, total flux in machine, so that is equal to P times of the P pi. So this is the total flux in the machine. So here phi is considered as a flux per pole. So total flux in the machine is equal to P into multiplied by phi. Okay. So next one, what about these parameters? Okay, what is the value of the Z here? Okay, Z is nothing but, so total number of armature conductors. Okay, these are number of armature conductors. Okay, this one is the Z value here. So next one, A is a number of the parallel paths. Okay, it is a is nothing but number of the parallel path here. So now here A is equal to the P per law of winding. Okay, per the law of winding. I will tell you what is the meaning of the law of winding. So why it is the A is equal to P, I will discuss in case of the construction details. And A is equal to 2 per wave windings. Okay, wave connected armature winding here. So now here Z by A in the sense, what is the meaning of Z by A? So number of conductors per parallel path. Number of conductors. So per the path, okay, per the path here. So here is a, suppose two parallel paths are there, and Z by A in the sense total number of conductors divided by the 2 will get the number of conductors per path. So now each path has the same voltage. So that's why we have to specify with respect to the per parallel paths. So alpha point P is a pole and pi Z A and Z by A is the number of the conductors. Okay. So now we have a question. So according to Faraday's laws of electromagnetic induction. So that is according to Faraday's laws of electromagnetic induction. So what is the here maximum value of induced EMF? The maximum, the induced EMF, okay, for So maximum induced EMF per conductor only. Okay, I have taken per conductor. So that is equal to E is equal to the BLV. Okay, BLV1. So we know this formula. E is equal to BLV, the maximum induced EMF per conductors. So now here again, what is the meaning of the B here? Total flux. Okay, in this sense, the here B is equal to, we can write here. So where what is the meaning of the B? So here the E is equal to B is a total flux divided by area of armature core. Area of armature core. Okay, that is the value of the B. So multiplied by, so next one, this is the L is the actual length of the conductors. Okay, actual length of, and E is the angular velocity. Angular velocity means the radius multiplied by the omega. Okay, omega values here. So now this angular velocity is equal to radius multiplied by omega. So omega is the angular speed and angular velocity here. So now simplify this. The E is equal to total flux is the P phi. Okay, area of the armature core here. So armature is a cylindrical structure. So for the, what is the area of the cylindrical? So now this one is the R. Okay, this one is the length. Okay, length of the air. So therefore, the area of the armature core is equal to 2 phi RL. So multiplied by the L, the into R, okay, multiplied by 2 pi N by the 60. Okay, angular speed, that is the 2 pi N by 60 here. So now simplify, okay, this 2 pi RL, okay, 2 pi, okay, 2 pi will be the cancelled out. The L and R will be the cancelled out. So that here E is equal to the P phi N, okay, divided by the 60, okay, B pi 1. So this is the only induced EMF, okay, for conductors, okay, per conductors here. Now induced EMF, okay, the induced EMF, okay, now we require, so induced EMF, so per the Z by A conductors, induced EMF in the Z by A conductors here, or induced EMF per parallel path, so that is equal to, so what about here, EMF induced per conductors, EMF induced per conductor multiplied by Z by A conductors here. So now therefore you can write the induced EMF, so per parallel path, so now this is denoted by the EZ here. So now simplify, so EZ is equal to P pi N by 60, the into, okay, P pi N by 60, so now multiplied by the Z by A here. So now therefore you can write EZ is equal to, okay, this is a EZ value, EZ, so that is equal to, so 5Zn by 60 to the into P by A, where P is the number of the poles. So this is the equation, generated voltage equations. So like this you can derive. Okay, all of it clear now? How do we derive this? So it is a armature core. Okay, it is a cylindrical structure, it is the length, and this one is the R, the radius of armature core and length of the armature core. So that's why we can write directly area is equal to 2 pi RL. So now this is the induced EMF per conductors, okay, and induced EMF per parallel path is equal to, each parallel path remains same. So the generated voltage is equal to pi Z by 60 into P by A. Okay, all of it clear now? So this is the how does EMF induced in the armature coil, and how to get the reversal of the current from the AC to the DC by using the commutation action. Next one, EMF equation of the DC generators. Okay, is that clear? So now let us discuss some observations from this discussion. observations from EMF equation. Okay, we have a questions based on this concept. So observations from the EMF equation are from this discussion. So first one, the EMF induced in the armature of the DC generator. Is it DC nature of the induced EMF or AC nature of the induced EMF? First tell me my question. EMF induced in the armature of the DC generators. Is it AC or DC? Very important. EMF induced in the armature of the DC generator. Very clear now? So what are the observations? One is the EMF induced in the armature of the DC generator is time varying nature of induced EMF. And second one is frequency of induced EMF in armature of the DC generator. So that is a F is equal to Pn by 120, where P is the number of the poles, N is the speed in the RPM. Okay. And third one is a, so what is the relation between? So let us discuss the third observation. So it is the relation between the relation. So generated voltage EZ the during operation of the generators. Okay, easy is a the during operation of generator are easy directly proportional to the speed and the flux. Okay, so this relation only possible in the during operation. So during operation of the generator, during the operation. So now here easy directly proportional to product of the speed and the flux. The remaining all are constant. So that means EZ2 divided by EZ1 the is equal to N2 divided by N1. Now that is a phi field flux pi 2 divided by phi 1 1. So this is a third observation. And fourth one is, so that is a the generating here motoring action in the generator. Motoring action in generator. Okay, and how do we get motoring action in the generator? So that is a the first one. So let us assume it is the north pole. Okay, N, and this one is the south pole here. So always flux lines are passing from north pole to the south pole. So now AB conductor is, okay, AB conductor, and this one is the CD conductor. So prime mover is a rotating, okay, in a clockwise direction. So this is the direction of the prime mover. So now here AB conductor and CD conductor. So EMF induced in the AB conductor and EMF induced in the CD conductor. So due to which current flows here. So this way due to this EMF current cross mark at AB conductor and dot mark at the CD conductor. So according to the Lorentz force law, okay. So then the force developed in the AB conductors, FAB, and force developed in the CD conductors here. So due to which here this, how do we find out direction of the force? So force direction is in the according to the left hand rule. So it is a upward direction, okay, downward direction. So this is an electromagnetic torque in case of the motor. So what we conclude in the generator also, okay, in generator, the motoring action takes place. Motoring action that takes place due to which electromagnetic torque produced in the armature. So which acts in opposite direction to the direction to rotor rotation. Okay, this is also another observation. Motoring action in the generator. In the motor also generating action takes place. So due to which here is the electromagnetic torque produced which acts in the opposite direction to the rotor rotations. Okay. So first observation, second observation, and third and fourth observations here. So these are all possible questions. We will discuss the question based on these observations later. So this is the end of the class today. So it is a official creatrix channel which has 150k plus members. Okay, and this is Unacademy Gate Telugu channel. So please join in these channels. These are the different type of channels under the Unacademy: Creatrix Gate, Unacademy Gate Mechanical, Unacademy Gate Civil, Unacademy Gate Telugu, Electrical Junction, Unacademy Questions, Unacademy Computer Science, Unacademy SSJE, Unacademy Engineering Foundation, Engineering Patashala. Okay, thank you very much.